when I hear that from somebody that their team is 10x more productive because of AI, what I hear is you have no idea how to measure the productivity of your team. We have not seen software companies make 10x their output in the past 2 years. No company has done that. Like they haven't like come out with like 10x the releases that they normally would, or like 10x the quality, or like 10x on any metric other than claimed benefits of AI in some cases. So the fact that Rock applications compile down to binary machine instructions, and so do the platforms, I don't think that has any security downsides at all.
Today we have a special guest, Richard Feldman.
Hello.
I first heard about Richard when I was watching a go-to conference talk about the Elm, the programming language. So that was many years ago, like almost 10 years from now. Since then, I was inspired by functional programming style, but I have never used any functional language in my professional life. Roughly 3 years ago, Richard invented this new language called Rock. I found about it from one of your talk. And it immediately drew my attention because of this one feature, that is the separation between the platform and the user code. So it sounds like almost like an operating system, but it's a language runtime. Maybe we can start from there, like what is Rock and why you have this separation.
Yeah, sure. So, thanks for having me, by the way. Happy to be here. So, the tagline of Rock is it's a fast, friendly, functional language. And so there's a lot of different aspects to each of those. So when we say fast, I mean two things. Fast as in runs fast, like your programs run fast, and then also fast as in fast feedback loops, like the compiler gives you feedback fast, the compiler runs quickly, giving you like type mismatches early rather than at runtime, things like that. In terms of friendly, we want to be very user friendly. So in terms of like nice error messages from the compiler, and also having a nice friendly community. And then functional, of course, it is a functional programming language. So the platforms and applications split, essentially the idea behind that basically came from my having a really good experience with Elm, and feeling that Elm was great in large part because it has this focus on one particular domain. Like Elm is like the whole language is built for building UIs in the browser. And that has pros and cons. On the upside, it means that Elm, like when you use Elm, it feels like everything is very coherent. The whole experience works together really well. The downside is that you can only use it for that one thing. And so with Rock, I wanted to try and see if we could sort of generalize that. So instead of making the whole language targeted for one domain, make a language that is sort of Elm-like or Elm-inspired, but target all sorts of different use cases, like writing scripts or writing web servers or writing native desktop applications or robotics, all these different use cases. And the platform's idea was basically a way to try to enable someone to make a sort of curated experience for a particular use case, where you say, here are the primitives that you have available, here's the operations that you have available. So for example, if you're making a command line app, then of course you want to be able to read and write to the file system. That just makes sense. But if you're building an app that runs in the browser, you don't have direct access to the file system, so it doesn't make sense. If you're writing a database extension, maybe you could decide to give arbitrary access to the file system, but maybe you don't want to. Maybe you'd rather intentionally not make that available, even though the database might have APIs for that. Those types of things. So putting all this together, we sort of ended up with this nice design where you have this formal first-class concept of a platform, and then the application is just something that's built on top of that. So if I'm building a Rock application, it kind of feels like I'm picking a framework, except that when I'm picking a platform, I'm not just getting these sort of foundational things that are helpful. I'm also getting this deeper integration with the operating system. So you mentioned like platforms kind of feel a little bit like operating systems, and a good example of that is how, unlike a framework like Ruby on Rails or something like that, Rock platforms actually get to be in charge of things like how memory management works. And so they can sort of silently behind the scenes give you better performance, or better latency with use cases like web applications, by using different automatic memory management strategies behind the scenes that are sort of tailored to that use case. And that's the same type of thing that Elm's able to do at a language level and Rock is able to do at the platform level. So when I'm building my Rock application, I'm just like, I pick a platform based on what I'm trying to build. And I don't necessarily need to think about those things. I just sort of get the performance benefits, and I get the like, oh, everything feels coherent, and like all the primitives that I have access to actually make sense for this use case.
In the past 2 weeks, I start to experimenting with some of the rock code. So I tried the basic Zed AI platform. I also tried the basic web server. Very interestingly, like some of the platforms are written in Rust, and
Hmm.
some of the platforms are written in Zig. And I know maybe this is because Rock is at its early stage, so some of the platforms are not as nice. But for me, at least at this stage, I feel like I have to know both rock, the language, and I also have to know the tech stack of that platform to write something meaningful. For example, I the basic CLI platform is written in Rust.
Hmm.
I did not know Rust very well. In that platform, there's no API to hash a file or hash a string. Well, which means I either have to implement that in Rock, so I have to re-implement a hash function, or I need to fork that platform and add some hash function from some popular Rust library.
Right.
But when I don't have that knowledge, then it is very hard for me to get into the Rock tech stack.
Yep.
So now the question is, do you think that's just a situation of an early tech stack, or you feel like that might be true for a very long time and it may require like elite programmers only to build rock applications?
Yeah, great question. Definitely a temporary thing. So the way that I like where I want to get to is where like so you gave the example of a hashing function. Anything that can really be expressed as a pure function, I think ideally you can just write in pure rock code. So if you need, let's say I need like a Blake 3 hash or a SHA-256, um, anyone can write that theoretically right now in rock and implement it and just publish a library. And so that's what we would call like platform agnostic. In other words, it's a library that can work on any platform because platforms are responsible for all the IO primitives, but any kind of pure function, you can just write that in rock. Now, granted, you might want to write it in the case of a hash function, you might want to write it in Rust or C or something like that, just because it's faster. And for that, you would do it in the platform. However, in the example of a hashing function, hopefully we can, I don't know, get good enough performance out of just writing it in rock, that it's fine. Because I think the best way for the ecosystem to work out is where whenever you have something like a hash function that's just pure functions and data structures, people write it in rock, you just pull that off the shelf. Now granted, today I don't know which hash function it was that you were looking for, but it sounds like nobody has implemented that in the ecosystem. But that's what I would want people to do in that case. Now the other piece was, do people need to learn this other language that the platform's implemented in? My goal is that if you want to build rock applications, you never have to learn another language besides rock. You can just be like, I just know rock and that's all I know. And when I look at this platform, I see in the documentation, oh, here's the rock functions that I expose. Ideally, I don't have to know at all what's under the hood. The platform is like, is it Rust? Is it Zig? Is it Go? I don't know. I don't care unless, the platform author is like using that as a marketing point, like, oh, we have this really fast Zig runtime, but I don't
Mhm.
care. Like it's like in the same way that I know that like Zed, the code editor, which is where I work, it's written in Rust. That's used as a selling point for Zed. But if you're using Zed, you don't need to know Rust, right? It's just like that's just the editor that I'm using, right? It's fast, cool. That's what I want the platform experience to feel like from an application author perspective. In my mind, it's like there's these two different authoring experiences. One is I'm authoring a application, and in that case, I shouldn't have to care what the platform is underlying implemented in. But then, if I want to get into platform development, then okay, then it's natural that I'm like, well, now because I want to actually work on a platform, now I do need to know that other language, the lower level language that's implementing the runtime for that platform. Um, but basically, I think ideally, application authors can just use Rock as if they would use Python or they would use JavaScript or whatever, and just use the normal language and not have to learn any other language.
Let's dive a little bit deeper into the platform stuff. Let's take JavaScript or V8 as an example. For example, we have Node, we have Deno, so they are both V8, but like the way they treat user applications, they treat those JavaScript as like data. So it's just a string. So,
Hmm.
and the runtime will read that string. Maybe it will do just-in-time compilation, but that happens in the runtime. or like we can take Java as an example. So maybe Java has like two-step stuff. Like first, let's use a Java compiler to compile it as a bytecode, and
Yep.
then the runtime will treat bytecode as data.
Yeah.
But for Rock, you've chose a very special architecture that everything is compiled.
Yes.
And because I don't really understand compiler at a very high level, I feel like will that create a lot of security issues? Because like the user code and the platform code are both compiled,
Hmm.
and we even download compiled binaries, like the platform binaries, and then do like static linking and put them into one binary.
Yep.
Like what's the choice behind that?
Yeah. Okay. So this is a great question. It's definitely not something I've talked about elsewhere. So, um, okay. So there's a couple of different interesting factors that when it comes to security. So one of the fundamental questions of security is, let's say that you have someone who is a malicious actor. They're trying to do something bad that you don't want them to do. What are they capable of doing? Like, what are they able to do if they're going to use whatever tool they can find using the whatever you've given them to do the bad thing that they want to do. Now, if let's go with V8 as the example that you gave. So in V8, like I give it some JavaScript code. If I'm running Node.js or Dino, actually Dino is a little bit different when it comes to security, but let's just go with Node.js. If I put inside my JavaScript code something that says like import fs, which is the Node file system module, and I just say like fs.write, well, I can write something to the disk. I can override files, whatever, as long as the currently running process has sufficient permissions to do those writes. So in that example, if I take somebody else's Node.js code and I execute it in V8, all that's going to do is like V8's just going to follow that code's instructions and issue the commands to the operating system to do those file writes or whatever it is that I asked it to do. Now, one of the downsides of the way that Node does packaging, like npm does packaging, is that by default, when you install a package, it runs arbitrary JavaScript code in V8, which can include things like modifying your file system. So even just doing npm install by default can change things on your hard disk in any folder, could overwrite things, introduce malware, whatever. So um, in Rock's case, uh, you did mention that like so Rock compiles all the way down to machine instructions, and essentially the point that I would make is that if you look at like if you open up the contents of a binary executable file, essentially what you're seeing is it's just a bunch of instructions that are just written down in a different way than they're written down in the JavaScript example. From a security perspective, what matters is not so much are these like individual ones and zeros representing UTF-8 strings, or are they represented like numbers that correspond to different machine instructions. What matters are the capabilities. What matters is, are you able to, using those ones and zeros, tell the operating system to do a file write or overwrite certain parts of memory. Fortunately, operating systems do a pretty good job these days. I shouldn't say pretty good, like a very good job of making it really hard for you to, within a currently running process, modify like the memory of other processes. It's really just like they kind of just don't let you do that. If your process attempts to do that, it's just going to crash immediately and not succeed at modifying the memory of other processes. Within the currently running process, it is certainly true that um, you can modify the memory of your own process that's like currently running and do various things in there. So in that sense, that would be the one example where I would say, compared to if you were just running a .js file as like sort of your framework, running a Rock platform means that you need to trust the platform that you're running on to not do things like read your application's memory, because they could write C code or whatever that can do that. Now, the reason I phrase that as if you are running a JavaScript framework that's just .js files is that Node.js also lets you compile C code into your Node application. You can just do that. You can just, as part of the build step, it compiles arbitrary, binary machine instructions into the Node application, at which point you have exactly the same security situation as Rock. So from when I think about it from a security perspective, I don't think that the Rock application like the fact that Rock applications compile down to binary machine instructions, and so do the platforms, I don't think that has any security downsides at all. In fact, I think it has security upsides, because in Rock's case, we have this design where the platform, yes, it compiles down to a binary, and also the application compiles down to a binary. But unlike Node.js and unlike pretty much every other language, other than specifically JavaScript running in the browser, it's the only other language I can think of that's like this. We don't allow you to compile arbitrary C code into your application or into your packages in the package ecosystem. It's really just the platform is the one and only place where that gets to happen. And what that does is it means that you have a much, much smaller attack surface area. In terms of capabilities, only the platform has the ability to run the arbitrary instructions. Everything else, that's the entire package ecosystem, that's the entire application, is only able to use the primitives that that platform exposes to do whatever they're going to do, which means that you have way more security in terms of like what do I have to worry about, because you really just have to worry about your platform. You do have to trust your platform, but in Node, in contrast, it's like you have to trust every single package in the entire ecosystem that you're using, which usually in JavaScript is a huge number of them. So I think we do better in security than pretty much any language other than JavaScript running in the browser. JavaScript running in the browser is the most locked down like experience that you can get right now.
For example, in a ideal ecosystem, maybe for example, we have 3 to 5% platform stuff, or even fewer than that. Maybe 1% of the code will be in the platform, and 99 plus of the ecosystem will be like rock pure function libraries.
That's what I expect. Although I think it's worth noting that I think that varies a lot on a case by case basis. So let's say you're building a web server, I think that's totally what you would expect. If you're building a command line app, I think that's totally what you would expect. But another way that you can use Rock is to have a huge platform and then a tiny bit of Rock code. So a good example of this would be like a game engine where you're like, I have this huge game engine, it's like massive amount of platform code, which maybe that's what I'm spending all my time programming, or I'm using some off the shelf, C++ game engine, and then I just want to use Rock for a little bit of scripting in my game. And so I've used the fact that C++ allows you to bring in whatever compiled binary libraries you want. Rock can compile to those, and then now I'm using Rock as this sort of supplement to this very, very large thing. Which, yeah, it's the same concept. It's the same concept of a platform and an application, but the way that I'm using it there is intentionally like, well, it's like, yeah, it's a platform, but it's like, otherwise, if I weren't using Rock, that would have just been the entire program. So um, I think that's a totally valid way to use Rock. Like both of those are totally like thin platform and huge platform are both totally reasonable.
This topic is related to another question in my mind, which is like the ecosystem size
Mm.
vs the ecosystem quality.
Mm-hmm.
Uh, so will you imagine that maybe in the future when Rock stabilized, uh, we will have maybe 3 to 5 popular platforms that does pretty much everything, and then we got application code? Or do you imagine that people still want to have their customized platforms for their stuff?
That's a great
Uh,
question.
for example, we have this basic web server,
Mm-hmm.
and for example, maybe they are running in some Linux environment and they want a special I/O capability.
Yeah.
Uh, and and this special I/O capability may not be necessary for other companies.
Mm-hmm.
So of course, if this is an open, if I am the maintainer of this open source project, like eventually this project's API will get fatter and fatter because uh, I want to make all my users happy, right?
Yeah.
So that's at least that's what happens to the popular ones. And do you think this platform application split design um, will not have that problem at a large degree, or maybe that's just a natural thing for software to evolve?
So I think it's going to depend on the particular domain that you're working in. So I would say that I would expect it to be different for web servers than I would expect it to be for, let's say, native desktop UIs. So with web servers, uh, when I think about like looking at other languages, what is it that different web servers offer that makes people choose one over the other? And in a lot of cases, what actually makes people choose one web server over another has a lot more to do with sort of tooling and infrastructure and like how much the database access, whether that's an ORM or something else, is integrated with the like session management and things like that. It's a lot of stuff that has to do with saving you time, like from having to write things from scratch that are really common in web servers. And that's kind of the major pitch. In contrast, when it comes to like UI, in a lot of cases, it's not really about that tooling and infrastructure stuff. It's much more about like, what is the actual interface for rendering a UI? Like, how do you deal with events? How do you deal with state management? It's much more about API design than it is about sort of like features and saving you time. So I think that will influence what the different competing platforms look like in different contexts. So, for example, in web servers, I actually think there's a pretty good chance that the main thing that web server platforms end up sort of competing on and using to differentiate themselves is actually their runtimes. So, for example, Volker de Vries made a runtime called Nia. So this is the idea was that this one's not ready for prime time yet. He sort of made a proof of concept of it, but the basic idea is the way that Nia works. And Nia, the reason he chose that name is he's Dutch and he speaks Frisian, and in Frisian, Nia is the word for never. And so the idea is it never allocates. So what you do when you build your web server on Nia is you say, here is how much memory I want each request handler to get. And you pick a number. So you say like 500 megabytes. I don't know, I just made that up. But you pick some number of megabytes that each web request handler gets. And what Nia does is it says, okay, every single time a new request comes in, I'm going to start running your request handler, and it just gets 500 megabytes. It doesn't do any garbage collection, so you never have any GC pauses or any time collecting anything. It just says you use more and more memory. And if you go over 500 megabytes, then that doesn't affect anything else in the web server. It doesn't slow anything down. It just says, nope, that request immediately becomes a 500 error and just returns a response that says, I'm sorry, I ran out of memory. Now, why would you want this? So the upside of this is that as long as you are able to pick a number that works with your hardware and works with your request load, it means things like your server just can't get bogged down with requests using a lot of memory, because if they ever go over, that individual request just gets cut. Also, you're spending the absolute minimum amount of time on memory cleanup, because every single request gets this fixed thing, and like once the request actually sends the response back, that handler is done, and that 500 megabyte chunk of reserved memory just gets reused and recycled immediately for the next request that comes in. So in terms of like how much time your server is spending on memory management, it's the bare minimum. It's really, really efficient in terms of that. Also, in terms of like predictability of like your load and things like that, a lot of times people will use things like Kubernetes to say like, oh, I need to make sure that we don't go over this memory limit. In this case, you're like, yeah, I don't even need Kubernetes for something like that because I can just set it in the platform. The downside is, what happens if the way that your particular traffic pattern is such that you have most of your requests are under a certain limit, but some of them occasionally need a lot more memory than that. Well, then Nia is not a good fit for you, because that's just your traffic pattern is you're going to have those outlier requests are just going to run out of memory and crash. So in that case, you might prefer a different platform that has a more traditional sort of each request uses as much memory as it wants, and if some of them go over, whatever. But the point is that having those different options means that, like, fundamentally, in terms of like, none of that has to do with database access or session management or any of those things. So
Right.
people can say like, I want to pick this or that one based on my runtime performance needs, rather than based on those other factors. So that's kind of something that I think it would be good if that ended up happening. And then for like session management and database management and stuff like that, those can be sort of like libraries in the ecosystem. And if you are able to make these sort of platform agnostic solutions to those things, and we already do have Rock PG is like a Postgres thing that's platform agnostic. It's not coupled to any platform. You can just use it on basic CLI or basic web server, whatever. And I don't think we have anything for session management dedicated right now, but you get the idea. Like, if those libraries are able to work across these different platforms, then maybe for web servers it'll end up being mostly about the runtime and about performance, compared to anything else.
Yeah, that's a great example. And I guess that's also why sometimes Rust got this criticism, right? Because freeing up memory also takes time, and Rust frees up memory very eagerly, like
Yeah.
at compile time, right? Like it already knows when to free. But for some kind of applications, they want arena or they want, like for example, like Tiger Beetle, which is written in Zik. They also have this like we will know how much memory we use
Yep.
before we start the application. So
Yeah.
all that kind of applications can be written as a rock platform, and then the rock application will be like just business logic or like a plugin into that bigger system.
An interesting thing, which I don't know if it's going to happen or not, but like in the web server example, I think if you end up with enough, uh, I don't know, commonalities in how the web servers offer their APIs, like for web servers, there's a really, really obvious baseline, which is like, give me a function which says I take in a request and I return a response and I can do some IO effects in between. If every web server offers that as the sort of like, hey, provide me with this request handler as sort of a baseline, that's really nice because it means that you can do things like you can sort of try out different platforms very cheaply. In the most extreme case, if they have exactly the same API, they can be drop-in replacements for each other. Where I can say, I don't know, let me try Nia, let me try Basic Web Server, let me try this other one, Kingfisher. These different web server platforms that each are, if they're offering the same API, then you can just say, yeah, like let's just see which one gets me better performance. Um, but yeah, I think when it comes to like desktop UIs, for example, I think it's going to be very different. I think in the same way that if you're like, oh, let me, you know, React is being kind of slow for me. Let me just try out Angular. You can't just drop that in, right? That's a whole rewrite.
But so speaking of APIs, like you mentioned, like for backend application, web server, maybe they have the identical API, like it's like request response.
Yeah,
Of course they do IOs, but besides the IO part, they are like very functional in a sense.
yeah,
So so my question is, like right now there like when we are thinking about rock standard library, I'm just thinking about like the pure functional part, like those data structures as my rock standard library.
yep,
The platform is not the standard library.
right.
But if many platforms start to discover this common API, and that might just effectively become the standard library of a domain, right? Will Rock as a language want to define the standard API for those domain, or
I
you
see.
want to left the choice to the platform authors?
Yeah, that's a great question. So, um, as an example, I'll talk about doing HTTP requests. So the current design, and I have a work in progress package to make this happen, but there's a few things we need to do before we can sort of like get this rolled out into the ecosystem and try it. But the basic idea is this. Let's imagine that I want to, in a command line app, I want to do an HTTP request. So I want to just make a request somewhere, get back a response, and handle the response somehow. Kind of like curl at the command line. Similarly, if I have a web server, that web server also might want to do HTTP requests in order to go talk to a third party whatever. So the idea is that let's say that we want to build some sort of library. I'm going to use Bugsnag. That's a like error reporting service I used at a previous job. Um, let's say that I want to have Bugsnag and make Bugsnag able to say, okay, I want to make a package for talking to Bugsnag. So it offers things like, oh, log an error, log a warning. Here's the message you put in. Give me your API key, and I'll just take care of talking to Bugsnag service for you. Really common package. Now, that Bugsnag package, it depends on the concept of being able to do an HTTP request, but it doesn't depend on any specific platform. Like I should be able to use that Bugsnag package for either my command line app or my web server, and it should just be able to work with both of them. So the idea for how to design an ecosystem where all of these things are possible does have something to do with what you're talking about there with like commonalities between platforms. So the idea is basically this. Step one is you make a platform independent package that's just talking about the data structures involved in HTTP requests. So basically, like the repo right now is github.com/rocklang/HTTP. And in that package, it's just got two modules, request and response. And all those modules contain are the data structures. Like here is an HTTP request that you can get the headers out of it, you can get the URL out of it, whatever, query string, and then the response again, same thing. It's like what's the status code, what's the the body, and all that. Just the data structures. Now, for the platforms, let's say that I'm making the basic CLI platform. Now I can just say, okay, I don't need to define request and response. I just grab that package and I use their definition of request and response. What I offer is the actual IO. So I offer a function called http.send, which is the most generic one. And then send has little wrappers like http get, which is like a send, but with a get request or post or put, all those things. All of those IO functions are just like, hey, give me the inputs and I will just construct one of these request things, send it off, and then get the response back and represent that as a response. Okay, so basic CLI can offer those HTTP things. Also, basic web server can offer those HTTP things. Now, here's where it gets important that we have the platforms and applications split. Let's say that somebody is now building a third platform that's going to run in the browser. In the browser, you can still have the same HTTP request and response data structures. That's fine. But inside the browser, you don't use the same things to do an HTTP request as you do in a command line app or in a web server. Because in the browser, you have to sort of proxy out to the browser's like fetch, for example. But the nice thing is that that can be an implementation detail of the platform, and the platform can still offer you the same basic API for doing the get and put and whatever else as you have in the command line app and the web server. And again, it can reuse the data structures of the request and response. Now, the Bugsnag package, which you want to work on all three of those platforms, what it does is it says, okay, one of the fundamental things about using any kind of logging system like this, or really pretty much any kind of third-party service, you have to provide an API key, right? You have to say, like, here's my API key, now go do the thing. The API key is a piece of state that has to be available every single time you want to do one of those operations. So the idea is that in most languages, what you would do is you would say, okay, here's where I'm going to provide this API key, state. Maybe I read it in from environment variable, whatever, but somehow I get you the API key. And then every time I'm using you, you're referencing that piece of state. The idea is we actually do two pieces of state in this Bugsnag library. One is the API key, but then right next to it, we also have a function that says, here's how to actually do an HTTP request. And so when you're starting up Bugsnag, when you're initializing it, instead of just saying, like in most languages, you would say, here's my API key. In Rock, you say, here's my API key, and also here's a function that lets you do HTTP requests. Now, that's not much extra work. If you're initializing it, it's just like one extra thing you're giving it.
It almost feels like dependency injection in some of those OO languages.
Totally. Yeah, it definitely has things in common with dependency injection. For example, testing. So one of the cool things about this is that, number one, it means that the Bugsnag library can be totally platform independent, because it's like, I don't know what your platform is, whatever your platform is, as long as it can do HTTP requests somehow, just tell me how to do it and I'm good, right? And Bugsnag is depending on those data structures of HTTP request and response, but that's it. It doesn't depend on any actual direct IO operations. It says you need to tell me how to do that. But there's actually several really cool benefits to this design. So one is, you mentioned like dependency injection. One of the biggest benefits of dependency injection in object-oriented languages is testing. So that's one thing you can do is when you're writing your tests, you can say, let me simulate what if Bugsnag returns a 500 error, or if it times out or something like that. And the way you simulate that is very simple. It's when you're instantiating the Bugsnag API key plus how to do HTTP request thing, you give it an HTTP request function that just always returns 500 or something like that. Or, the first time you call it, it returns this, but then if it gets a particular string for the URL, then it returns 500, whatever. So you can just simulate that in your tests. And in your tests, you're not really doing any IO, or you don't have to be, because you can just override that. The second thing that's cool about this is not only is it possible for you to use this across multiple different platforms, but also you can use it across multiple different platforms, even if they have slightly different APIs around how to do HTTP requests. As long as you can translate it into the format that Bugsnag wants, you're fine. So you don't even have to have a completely agreed upon standard for like what an HTTP request looks like, as long as you're able to translate it. So this means that different libraries that might expect slightly different things, it's okay because they're like, well, just give me a function that takes this as an input and then returns this as an output. As long as I can make one of those functions and give it to that library, I can use that library. So it means that you have this like extra sort of layer of compatibility sort of baked in. You don't need to like wrap the whole library. It's like, no, just this one function is where I'll do my translation if I need to do any. Hopefully I won't. But if I do, it's just in one place right when I'm initializing the library, and then I'm good. The third thing that's really cool about this is security. So let's imagine that I'm using this Bugsnag package and it gets taken over by a malicious actor, somebody who wants to use it to mine cryptocurrencies and then send it off to their servers or whatever. Well, one of the cool things I can do is when I'm giving Bugsnag, the library, this function for how to do HTTP requests, I can give it a sandboxed function for doing HTTP requests, such as, for example, when I get in the request and it says, hey, here's the request I want to make, I can look at that request and say, hey, if you're trying to make this request to any URL other than api.bugsnag.com, I'm just going to not do the request and just return a 500 error immediately. And so now if it gets compromised and someone's like, oh, I'm going to mine a bunch of cryptocurrency on your server and then send it off, to my servers, it's like, no, you're not. they're not going anywhere. You can send your mined cryptocurrency off to Bugsnag's API, but that's not going to get you anything. So in that way, you can further insulate yourself from any kind of concerns about what your packages are doing. And the cool part about all this is that because a platform agnostic package is not even able to depend on a package. Like if you publish a rock package, it can't formally say I'm using this platform.
Not even in the file, like the import
Right.
this platform.
There's not even syntax for it. Yeah. So because of that, that any package that you get, it's only possibly capable of doing the IO that you tell it how to do. That you, as the application author, you have to give it permission. So they say, you can do this IO, I can sandbox as much as I want, and they don't have any escape hatches where you can get around that. So yes, there was a little bit of inconvenience in that when you're creating it, you have to say API key and give it this function, but you only have to do that once in one place. And it has all these really amazing benefits for testing, for security, for compatibility across the ecosystem. So that's kind of the design. To get all the way back to your original question about like, do I think that a sort of de facto standard library that like everybody ends up using in practice across all the platforms will emerge? I don't think there will be one, but I do think that there will be like use case specific ones. Like I do think there will be a common like, okay, here's what an HTTP request and response look like, and everybody builds on top of those. And like similarly for like dates and times and things like that. But I don't think there will be a whole like full set of them that everyone just kind of imports. I think it'll be more use case specific like HTTP. The Rock standard library itself is pretty small. I think it's like 10 modules right now, something like that. It's like strings, lists, numbers, dictionaries, sets, a couple things like that, like result. We have talked about maybe adding a little bit of like date time stuff, just because it's like pretty small and simple. One of my guiding principles for like what should go in the standard library is it's things that don't need to be versioned a lot. So for example, we intentionally don't have anything to do with Unicode in the standard library, because Unicode has new releases. Like we're on version like Unicode 4.0 or something like that. Like there's going to be a new Unicode release. And sometimes they're, backwards incompatible changes, or at least they can be. So because of that, we want to have all the Unicode stuff in a separate package that's versioned separately, so that you're never in a position where you're like, oh, there's a new version of Unicode, I want to upgrade to that, I have to wait for the next release of the Rock language. We want to just be able to be like, no, they can just, anyone can go and update the Unicode package in the ecosystem. You can just get the latest version. You're fine. And if it's a breaking change, maybe you don't want to upgrade, right? You don't have to upgrade when you get a new version of the language. So I think that's important. But then in contrast, we have something like, for a long time, we didn't have any any functions in the standard library for doing uppercase and lowercase, because those rely on Unicode. If you want to do it like correctly across, all languages, uppercase and lowercase. But we did realize that in a lot of cases, what people wanted to use the uppercase and lowercase for was just like JSON or something, where they're like, I don't actually care about all the Unicode stuff. I really just need the basic ASCII ones, like the American like letters. And as a consequence of that, what we ended up doing is we added to the string module the ability to do specifically ASCII uppercase and lowercase, because ASCII is not versioned. It's like hard-coded, fixed permanently, like well specified, never going to change. And so that one, it's like, okay, we can put that in there, but it's obviously not like the complete functionality, but it's never going to change. So yeah, so the idea is that we don't want the standard library for Rock to be like getting bigger and bigger and covering more and more use cases, but rather it's like we want to be very careful to make the things that are in the standard library things that are really stable and reliable and not like and also not ideally open to a lot of design debate. It's not like there's like a million different ways that you want to represent a string. It's like there's kind of just like one is really all you need for strings. And in fact, languages that have multiple different string representations, it's usually considered a downside. Whereas in contrast, there's like lots of other libraries where it's like, oh, there's no consensus on how to do it right. So like times in terms of like durations, I think is fine. Like, hours and minutes, not that controversial. Representing like an instant in time is like number of nanoseconds since the Unix epoch, like that's also fine. But then as soon as you get into like dates and calendars and stuff like that and time zones, now it's like, okay, this is something where I would want to think a lot harder before putting that in the standard library, because there's a lot of different debate about like what's the best way to do that.
Let's dive into something totally different,
Okay.
which is AI. Um, so I know that you are working on that, the new code editor, and you
Yes.
mentioned in other podcasts that you are working on something relating to AI.
Yes.
You can talk about that part if you want, but my question is, as a software engineer, do you think I should care about AI?
Oh, absolutely. So here's the way that I think about it. When I had my first programming job, which was 2004, um, I walked in the office and I was an intern, and I told them that I knew how to program. At first, they didn't give me programming tasks. They had me sorting CDs, like compact discs, and like putting labels on them. And I was like, hey, I can program. I was hoping to do programming in this internship. So I said, okay, here's a desk, here's a computer. We're going to have you write some code. And this was Java code at the time. And they asked me, are you going to be okay without a bookshelf? And I said, what do you mean? And they said, well, for all your reference manuals. And I was like, oh, I actually just read my reference manuals online. I go to like the Java, like, at the time it was java.sun.com. Now it's on Oracle's website, because that was back when Sun Microsystems was still a thing. But basically, like, I felt like, oh, if you're still only using books as your reference, you're really missing out, because like I can do search. Like I don't have to like go look in the index and like find, okay, wait, where's this concept? Oh, it's on this page. Okay, scroll back to that page. I can just like type into the search box like what thing I'm trying to look up, and then there's hyperlinks. So if like I'm reading along and I'm like, oh, what's that type? I can just click on it. It just speeds me up. It makes me go faster. So it's not like you can't do programming without online docs. Of course you can. You can use it with reference manuals, but it just feels like you're kind of missing out if you don't give yourself access to that new tool that's available. I feel the same way about AI today. When people say things like, "Oh, my whole team is 10x more productive," I'm like, "You're what when I hear that from somebody that their team is 10x more productive because of AI, what I hear is you have no idea how to measure the productivity of your team, or else you're in an extreme outlier scenario that doesn't apply to people, and you probably shouldn't be acting like that's general advice, because obviously, like, we have not seen software companies make 10x their output in the past 2 years. Like, no company has done that. Like they haven't like come out with like 10x the releases that they normally would, or like 10x the quality, or like 10x on any metric other than claimed benefits of AI in some cases. So I know, like, I don't think it's that. To me, it's like it's not even 2x. It's like I'm like 1 point something x faster, in the same way that, like, with the documentation example. So in my mind, it's like, to your question, like, should I care about AI as a programmer? I think yes, just because if you're not using it, you're missing out in the same way that you were missing out if you had a bookshelf full of reference manuals and no access to online documentation. Um, is it going to completely, change like everything about programming for you? It certainly hasn't for me. I don't think it does for most people, but I will say that it varies a lot by use case how much you get out of it. So if I'm working on Zed's code base, for example, it's really kind of a convenience. It's like, I'll be so like one of the features that Zed AI has, which depending on when this podcast goes out may or may not be generally available. Right now it's like, if you build from source you can get it, but not everybody has it, which is basically the ability to do like tab completions on the page really quickly. So you can basically, you'll see this little like suggested text, and I use this with Copilot, something similar, and I didn't like it. But the way that we've done it in Zed, I actually do like it, so I've actually started using it. But a really, really common example will just be that I make some sort of little change in one piece of code on the screen, and it's not quite as mechanical as a rename, because of course with rename I can just use like F2 and it'll just do it across every single place. But
Yeah.
it's something similar where it's like, well, I'm changing this name from this thing to like I'm adding an underscore and then something else at the end of the name, like I'm making the name a little bit different. um, but it's something that's just like not quite mechanical enough that like a language server can do it for me. um, Zed AI is really good at making it so that, oh, there'll just be a suggestion of like, did you want to do that in all the other places this appears? And I'm like, great, tab, 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 done. Previously, I would have had to write that out by hand. Am I 10x more productive because of that? Of course not. It's just a convenience. But there are other scenarios where it actually makes a really big difference. And the scenarios where it makes a really big difference for me are where like the most useful thing is where I'm in the exact situation of I want to write some code from scratch. Usually it's going to be something throwaway that I'm not going to keep around long term, but it's in like using a technology that I'm not familiar with. So it's basically like it's like a super template kind of like, or like really really easy example of this was I'm working on this course for teaching C. And I wanted to use as an example in this course building a static file web server in C. Now, I could sit down and just with an empty text file and start writing that from scratch, but I'm going to have to go look up a bunch of things because I don't write static file servers in C all the time. Um, so what I did instead is I just asked an AI, like I think it was Claude 3.5 Sonnet, to be like, hey, can you just write me a static file server in C? And it writes me something. And I say, okay, please make this change and that change and that change. And then it's able to sort of, make tweaks here and there. And eventually I get something where I'm like, okay, this isn't exactly what I want, but it got me so much closer that now I can just go through and make edits as opposed to having to write every single letter by myself, from scratch. So in that scenario, that saved me a bunch of time having to go look up docs. And like I think, the first one that gave me like didn't even compile, but like I can go through and fix those compilation errors. And if I look at like how much time did it take me to get to the static web server from scratch that I wanted using the help of AI versus if I'd done everything myself, I think it definitely saved me a significant amount of time, especially like looking up documentation time. And if I look at the before and after of like, do I think that it was like higher or lower quality? I honestly think in that case, it's about the same. The thing where AI is not nearly as helpful or like as beneficial to productivity, in my experience, is when you have a really big, complicated code base. Um, Currently, nobody that I'm aware of has really cracked the code of like, how can you really get like big benefits out of the current generation of AI models. And the big limitation there is just their context windows. Like you cannot copy paste your entire couple 100,000 lines of code, code base into Claude and say, here's my whole code base. And now I want to ask you some questions about it. Like, where do I go to do this change? Or, make a huge refactor here. It just can't do that because it's like, that's too big. I cannot fit all of that in its, working memory. So that's I think the main limitation for the type of work that I do. Um, but I've found enough smaller things that I'm just like, yeah, this is something where if you took it away from me and you said you cannot use AI anymore, I don't think I'm like, well, now I'm a terrible programmer. It's more like, well, I'm going to be a little bit slower.
So the AI capability of Z also uses those popular models like GPT or Cloud, right?
So we have a few different AI features, and it depends on which one you want. So there's a general sort of like a direct chat interface where you can just sort of have like you say something, it says something back. You say something, it says something back. And in that case, what you're using Zed for is basically a very quick way to get like chunks of code into that message rather than having to like copy paste them into a web UI or something like that. So it's sort of like more convenient chat GPT. In that case, there's literally a drop down. You can select what model you want to use. The Zed AI thing that I was talking about with like the tab completions, that's something where we actually, well, we didn't train, but we fine tuned a model ourselves that was designed to be like good at this use case. The reason we did that is because when you're doing like tab completions and stuff like that, for the experience to be good, the model has to give you an answer very, very quickly. And in order to get very, very quick answers, you really need to use a small model. If you use a really, really big model, there's just going to be a delay there. And if you're using a really, really small model, then it's kind of limited in how much it knows. And so you kind of need to fine tune in order to make sure that it knows enough about like, little quick code completions like that use case to still give you good answers. So in that case, you can't just be like, give me Claude, give me, GPT-4 or whatever.
Are you aware of like Cursor or Windsurf?
For sure. Yeah. I've used both of them.
What will be the biggest difference between Zed AI and both of those editors?
Yeah. So I would say the main difference is just that they have a head start. Like they were building AI features before we were. And so they just have more of them. Of the AI features that we've built, when I ask, like, if I say, like, forget about all the other features, if you just look at, like, how do we do at tab completions versus how does Cursor do at tab completions, I think we're about on par. I've heard some people say that they like ours better. I've heard some people say they like Cursor's better. Maybe it just depends on what your code base is. Because, of course, we fine tuned our own model and they fine tuned their own model. So there's going to be some differences. Also, when it comes to the like the chatting back and forth experience, also there's some UI differences between ours and theirs. I don't think those are like really fundamentally different. I'm personally excited about some new things that we're going to be building in 2025 that I think will be differentiate us more, like specifically in the area of AI. But certainly, like whenever we talk to people, like I had a friend who asked me like, "Hey, we're really interested in like AI features, like what are some things that like Zed does to stand out from Cursor and Windsurf." And I have to be honest and say like, well, we're behind right now. Like they started with the VS Code base and added this, whereas we started with empty code base and built the whole editor from scratch in Rust to be really, really fast. And so, Zed does feel snappier and more responsive and quicker than any VS Code fork because it's built for that. And that's sort of like a permanent advantage that we have. But we are behind on like developing AI features. So we're working on it now a lot. But yeah, I think Cursor had been around for quite a while building AI features on an existing code base before we even started on that.
One last question. So it's a question about career development for my audience to know more about you as a person. So when did you start programming, and what's your first job?
So I started programming when I was 9. It was basic, quick basic. I bought a book called Learn Basic Now, uh, and well, my dad bought it, and then I taught myself from that, and then I got into like Visual Basic, and then I wanted to make games, and I heard that C++ was what people use for games, so I learned C, and then C++, and then Java, and my first programming job was 2004, like I mentioned earlier. It was a summer internship, and the way that I got that job was actually. I didn't even apply. It was just that some girl at my school, her mom worked at this company, and my dad was asking, I guess, parents that he knew if anybody had any summer internship programs where you could do computer programming, and that was the one that came up, and it was a pretty straightforward process, I guess. It's hard for me to give career advice to people now because I just think that it's so different. Like, first of all, there are way more programming jobs today than there were back then, but there's also way more programmers. Also, the types of work that people are doing is very different. Like at that first internship, we didn't use source control. Like there was no Git, there was no nothing. It was just like you saved it on your computer, and then when you wanted to get it added to the main code base that was gonna go be deployed, I like emailed it to someone. Like that was the process. Obviously things are just like so much different now than they were back then. There was no like at least at that job, this changed with other jobs, but that particular job had a rule of like you can't use any libraries. Everything had to be written from scratch in house.
Which was crazy to think about today, right?
Right. Yeah. I mean, I'm sure there's probably some industries where you have to do that today. Back then, I was sort of like, oh, okay, well, I guess I'll just write everything from scratch.
Thank you very much, Richard. I have learned a lot from you, both in the topic of rock as a language and about AI technology. Ladies and gentlemen, Richard Feldman.
Thank you
Thank
so
you very much.
much. 谢谢。
Great. 谢谢。